Very greetings to all. This is Dr. Agnibha Das Majumdar, and I am currently working as a assistant professor in Department of Physics in Madanapalli Institute of Technology and Science. Today, I would like to present one topic that is include my research topic, and that is about the near infrared spectroscopy, a promising tool for the food industry. So in this topic, I would like to present something, the impact, good impact of the positive impact of this particular technology, that is near infrared spectroscopy. And this technology, how it is impactful for the food industry, how it became a promising tool for the food industry, that we will see in the coming topic. So this is the flow of presentation, where first I will cover the introduction. Then after the instrumentation of the near infrared spectroscopy, then I will come to the need of the near infrared technology. And after that, I will go to the advantages of the near infrared technology. And finally, I will summarize the topic with the application of the near infrared spectroscopy. Okay, so this is the introduction. In introduction that I can tell you, there are total 3 points. So first we can discuss what is the demand of the product quality improvement. So product quality improvement means in food science, we are having different food products. So if I want to improve the quality in a non-destructive way, there itself we can use near infrared spectroscopy. So how it will come? Suppose you want to check the quality parameter of any fruits or any food products, or it can be any pulses, it can be any cereals, anything. So if you are going to check the quality of the food produced from the food industries, what we can do, we will go for the chemical analysis. So the people who are working in the food industry, they will go for the chemical analysis. But after doing the chemical analysis, the product is now a garbage. Now we have to throw it out, which definitely will create some garbage in the environment. Now next thing, whenever we are doing the chemical analysis, whatever chemical we are using for the analysis, that is also not good for our environment. So it will make a very bad impact on our environment. So with the help of this technology, that is near infrared technology, definitely we can see the quality of any product without using any chemical method. That means this method proves itself as a green and non-destructive technique. And there is also a need of rapid non-destructive technique, which is not so very bad, which has not so have very bad impact in the our environment. So, and last thing is the emphasis on the food safety. Whenever we are going for the food safeties, this technology will help us in terms of what? Whenever we are going for the market, whenever we are checking any fruits, the fruit is good or not, what is the quality of the fruit. If there is any insects, it is not good for our health. So with the help of any near infrared technology, we can make any handy product, any handy this instrument. With that instrument itself, we can check the food product, what is the quality of the food product, which will impact on our health. So in this way, this near infrared technology can emphasize the food quality and the food safety also. Now I'm going to discuss something about the electromagnetic spectrum. Why this slide came? Because if I want to discuss about this near infrared technology, so what is the source of this technology? The source of this technology is near infrared spectra. So whenever the near infrared spectra is interacted with some material or some matter, then this spectroscopy will take in the place. Now the point is, from where this infrared can come? Infrared can come from the electromagnetic spectrum. And what is the electromagnetic spectrum? This electromagnetic spectrum consists of total 6 parts. What is that? First is X-ray, second is ultraviolet rays, third is visible rays, fourth is infrared, fifth is microwave, and next is radio wave. So if you see all these waves, these all together consist a spectrum that is known as electromagnetic spectrum. So with this X-ray, you can use for some medical purpose. Ultraviolet rays also you are using for some medical purpose itself. Then if you are going for the visible rays, whatever we can see around us, that is a visible ray. And after that, microwave ray we are using for heating purpose in microwaves. Radio waves are using for the communication system. So instead of all this, if we focus on the infrared rays, it will have a more good impact on the technology, and it will have a more impact on the food safety and the food industry. If we see the infrared region, it is having three sub-regions. First is near infrared region, second is mid infrared region, third is far infrared region. So if I am going to near infrared region, the wavelength of this region is from 0.75 to 2.5 micrometer. If I am going to the mid infrared region, what is the wavelength of this? The wavelength is from 2.5 to 25 micrometer. Now if I am going for the far infrared region, what is the wavelength? The wavelength is from 25 micrometer to 1000 micrometer. So if we are going from near to far, the wavelength will be increased. Now this slide says that what is the source of near infrared spectra. So for this near infrared technology, what we need as a source near infrared spectra. So our natural source of near infrared spectra, or natural source of any infrared spectra, is sun. So from sun itself, all the rays of the electromagnetic waves we can have. So first is what? First is your UV rays, then is your visible rays, then is your infrared, then is your this microwave rays, then radio waves, gamma rays, X-rays. Every rays you can have from the sun as a natural source of electromagnetic spectrum. So now near infrared spectroscopy is also a rapid, a non-destructive and a reliable technique without the need of sample preparation. For that reason, we call it as the rapid method. Here we don't need any sample preparation, just we need to keep the sample in the spectrometer and the near infrared will come and it will show us the result. How it will show us the result in next slides I will tell you. This is NIR spectroscopy. So before going deep down knowledge, before going to know the deep down knowledge about the NIR spectroscopy, first we need to clarify the term what is spectroscopy. So let's see what is spectroscopy. You can see in the slide itself, we have written that interaction of electromagnetic radiation with the matter. As I have discussed earlier also, spectroscopy can define as the interaction. It has the interaction between electromagnetic radiations with any material. Then the use of near infrared region is rely from what? From 800 nanometer to 2500 nanometer. And it can penetrate much farther into a sample than the other radiation. So what is the importance of the near infrared technology? Why we are taking near infrared specifically for the food science? Because it can penetrate much farther into a sample than other radiations. Also, it based on which topic? It based on which principle? It based on the molecular overtone and combination vibration principle. So used for the it also used for the quantitative measurement of the organic functional groups, especially the OH group, that means your hydroxyl group, then NH group and the carboxyl group, that is C double bond O. So what is that? This is how the near infrared spectroscopy works. See, there I am showing you there is an interaction between matter and energy, and that is in terms of light energy. So what is light energy actually? The light energy is the infrared radiation or the electromagnetic radiation. If electromagnetic radiation and the this matter are interacting with each other, then absorbance will occur at some resonant frequency associated with the atomic and the molecular vibration. If you see here, you can see the systematic stretching and symmetrical stretching and the asymmetrical stretching. So two parts are there. So here stretching means what? There is a bond between two molecules. So if the energy will come from the radiation, that energy will absorbed by the atoms of the molecules. So whenever they will absorb the energy, the molecules will vibrate in each other. with each other, it will vibrate. So after the vibration, what we can see, the vibration will increase as the amount of energy will increase. So suppose there is a range of energy or there is a range of wavelength. So how we can measure the energy? That we know E equals to h nu. And if you convert that nu with a lambda, what we can have, E equals to hc by lambda. So as lambda will increase, your energy will decrease definitely. So with the increasing of lambda, energy will decrease. So if we decrease the lambda, definitely energy will increase. So as the energy will increase, more energy will absorbed by the molecules, and as the more energy absorbed by the molecules, the vibration also will increase. So the vibration can have different two types. It can be symmetrical vibration, it can be asymmetrical vibration. In symmetrical vibration, all the molecules vibrating in a same way. But in asymmetrical vibration, all the molecules vibrating in a different way or in an asymmetric way. That's why it is called as asymmetric vibrations. Now, the NIR absorbance can be done with such kind of molecules I have shown you. That is CH molecule, NH molecule, SH molecule and OH molecule. These all molecules can absorb the near infrared spectra or the near infrared vibrations. Next is what? Visualize bonds between the atoms as a spring. Now this vibration method we are converting into a spring model. So in the spring model, what we can see, if there are two balls and if that two balls are attached with a spring, and what we can do, if we are giving some more energy to stretch these two balls, that distance between two balls will more. And again, if we give some more force to compress them, the distance between these two balls will be less. So the same thing will going on with the vibration of the molecule. So what I have written here, the classical physics consider the atoms as the particle with a given mass in the IR absorption process. The vibration of the diatomic molecule describes as follows. Example we can take as a HCl. So HCl means we are having a bond between hydrogen and chlorine. So HCl means one we are having the hydrogen atom and another way we are having the chlorine atom. Between them there is a distance and there is a bond between hydrogen and chlorine, and it will make a hydrochloric acid, that is HCl. So if we are stretching them by applying some energy and force, stretching them, the distance between these two the atoms will be more. But as it is a spring, and with this it will try to come into its primary position. So again automatically it will compressed. So here and there what will happen, a compression stretching will take into the picture. So this thing only follows whenever we are giving some energy in terms of IR radiation, and it will compressed and stretched, so vibration will take place. Okay. So this is the kind of modes of propagation of light. Here what we can see, this is a transmission, and the second type is reflectance, and third type is transflectance. So transmittance, reflectance and transflectance, three types are there. With this three types, we can see the mode of propagation of light or mode of interaction of light with the matter. For transmittance, what we can see, for transmittance spectroscopy, the light will come and it will transmit through the matter or the substance. For reflectance, from the surface of the material itself, the light will come, the IR radiation will come and it will reflect back. And for transflectance, it will go inside of the material, but within the material only it will again reflect back. So for transmittance also, the ray will have the information about the material while it will transmit through the material. In reflectance also, it will gather the information about the material from the surface of the material. In transflectance also, it will gather the information from the surface as well as from the within the material itself. So among these three types of propagation, last propagation, that is transflectance propagation is most useful and impactful propagation system of this kind of studies whenever we are using the infrared spectroscopy to know some or to resolve some problems of the food science. Okay, this is the instrumentation. In instrumentation, what we can see, this is a near infrared spectrometer. In the near infrared spectrometer, you can see this is the sample. So in my research time, when I was doing the research with the near infrared spectrometer, I was using the mango pulp here. So I am showing here in the slide the mango pulp. So instead of mango pulp, you can use any food product, any kind of food product you can use. That can be any cereal, that can be any pulses, that can be any fruit pulp, that can be water also. So whatever biomaterials are there, you can use any extract of any leaf extract, anything you can take, or any flower extract also you can take for this kind of analysis. Just you have to keep it on this sample holder, and you have to keep that sample holder within the spectrometer. So from the source itself, light will come in the sample holder. That light will fall down, and either it will follow the transflectance, or it will follow the reflectance, or it will follow the transmittance method. So it will depend upon the instrumentation and the features of the instrumentation, what method this instrument will follow. This particular instrument in my lab, we have used the transflectance method. So in transflectance method, what will happen? From the source, the IR radiation will come and it will fall on the sample, whatever sample I kept here, it will fall on the sample. So it will go inside the sample as well. So it will collect the information, or collect this information about this sample within the sample also, and the surface of the sample also. So what information it will collect? It will show some spectra. So there in the spectra itself, why it will show some spectra? Because whatever bond will this vibrate, and the frequency of the vibration and the frequency of the IR radiation, if both will match, it will call that resonant frequency. If both will match at the same frequency, the molecules will absorb that radiation. So if there is no absorption, light will come as output. We are getting the light as a straight line. So if some absorption will come, definitely a dip we can have. So straight line means here absorption, again some dip, again straight line, some absorption, dip. So amount of this absorption will show us the strength of the dip. If the dip is so long, the absorption is too much. If the dip is very small, the absorption is very small. So this is the instrument. This is the different parts. You see, first is the source, then it is collimating lens. Then we are using some filters. Why we are using some filters? Okay, so first this is a source. After that, this is a collimating lens. Then we are using the filters. Why we are using filters actually? Filters means if you see the earlier slides, what we can see. Actually, we can see the near infrared spectra have some range. Okay, so from 0.25 micrometer to 2.5 micrometer, that is having a range. That means 250 nanometer to 2500 nanometer range. Now we don't want all the this wavelengths at the same time. So a particular wavelength will come and it will interact with the sample. Then only we can have the fruitful results. That is why from the source a range will come. What is the role of this filter wheel? One by one the filters will come. So whatever is the that color of the filter, that particular color will go, other color will be absorbed by that filter. Suppose the filter is having red color, and the red color this wavelength is suppose this 7000. So 7000 only will pass. Now here it is not 7000 because it lies between the 750 to 2500. So whatever color present in the filter, that color itself will absorb that particular wavelength of the light, and that will pass the particular wavelength of the light, other wavelength will be absorbed. In this way we can have a particular single wavelength as the output. After that, what is that? That is bifurcated cable, that we can join all these filters with the detectors and sample holders. After this is the oscilloscope. In the oscilloscope we can have the output of this material. Next is what? Next is radiation source. So now we'll discuss the different sources or different parts what we have discussed in the last slide. So as a radiation source or as a source of this near infrared spectra, what we can use the halogen tungsten lamps, or which will have the or any source which will have the this wavelength of 780 to 2500 nanometer. This is a dispersing element. In dispersing element, what we can see, we can use the monochromator, we can use the filters, we can use the gratings. This dispersing elements means what? That is a filter only. So in filters, that if we are using monochromator, that means if all lights are coming, particularly some particular light which is known as, that maybe, which is known as monochromatic light, single wavelength light, it will pass only monochromatic light, it will pass only the single wavelength light. Filters also same, it will absorb other wavelength and it will pass a particular wavelength. Now next is grating also will have the same application. Next is your sample holder. As a sample holder, different thing we can use quartz cuvette, we can use a dish sample holder, also we can use liquid sample holders, because the sample whatever we are using, it can be a powder sample, it can be a liquid sample, or it can be any solid sample. So for different samples, different kind of holders or this cuvette we are having. So whatever will be the need of use of any sample holder, accordingly we'll use that one. Next is your photo detector. As a detector, what we can use? We can use a device that senses the light. That's why we are calling it as a photo detector. Photo detector means if anything in terms of photon it is coming, the detector will detect that particular photon and it will convert the light signal or photon signal to the voltage or the current. And in terms of voltage or current, we are getting the output. So what material can be used as a photodetector? We can use the silicon material, that all the semiconductors we can use. We can use the silicon material, we can use the indium gallium arsenide, or we can use the PBS. Okay, so anything we can use as a photodetector in this system. Next is, what is the need of this NIR technology? So we have learned what is NIR technology, we have learned what is the source of NIR technology, we have learned from where we got the NIR technology. Now next we have to learn that what is the need of this NIR technology, why we are using NIR, why number of times sir is telling NIR, what is the role of this NIR? The NIR full form is what? That is near infrared radiation technology. Near infrared radiation technology. This technology is important for various fields. Here I will show you some important fields during the food technology, or the which will have some impact within the food technology purpose. So if you are going for agriculture, you see I am showing here one picture. The farmer is plucking the seeds, everything, the plants they're plucking. So after collecting the seeds, after collecting the cereals, after collecting the pulses, what we are doing, they are sending that thing to the industry. Now industry will see that particular seeds or that particular pulses or cereals or that particular food products, these are good or not. So to check that quality purpose, we are sending this to the food industry. So food industry people, what they will do, they will, before purchasing that one, just to see this point, before purchasing from farmers, they can check thoroughly what is the quality of those things sent by the farmers. Okay, next is what? Next is the fruit. If you go to the market, so you can make with this technology a very portable and handy product. You see there itself, this is the fifth picture, big picture. There, what I am showing to you, it's a kind of portable NIR spectrometer. With this portable NIR spectrometer, what you can do, just if you just touch it with any product, it will show the quality of that product. That quality, maybe it is what is the shelf life. If you make a product, if you make this NIR this portable digital meter, NIR meter, with this NIR meter, what we can see, with this NIR spectrometer, we can see the level of maybe we can see the level of protein present in the particular food product, or we can see the level of sugar present in the particular food product, or we can see the level of protein that food product can produce, or which amount of carbohydrate, which amount of fiber that particular product can produce, that we'll see. So suppose you are going to market and you are checking all the fruits are there. Now what you need to do, you need to grade and sort that which fruits are very good in nature, and definitely there is having some shelf life of any fruit or any food product. If that food product will cross the shelf life, some bacteria will come to that fruits. If I am talking particularly about fruits, we are going to fruit market, vegetable market. If that fruits or vegetables have crossed the shelf life, definitely some bacteria will come, so which is not good for health. Now I am telling you what is the role of NIR technology for the food safety. So if you make a portable and digital this spectrometer, NIR spectrometer, so this portable means anywhere, it's a very handy, anywhere you can bring it. So in market, and if it is very easily available, maybe people can buy this, and they can bought this in they can brought this in the market, and if while purchasing the fruits or any vegetables, you can just touch on that particular vegetable, and that particular this instrument will show you what is the quality parameters of that particular fruits or these vegetables. Okay, so this is the main motive of this NIR technology, to grade and sort the good products. If you are going for any beverage company, suppose if you are going for an industry that is fruity. So if you are going to the this fruity company factory, what they are doing, they are purchasing mango from the farms, and they are grading and sorting the mangoes, and the good mangoes, bad mangoes, they are sorting. With the good mangoes itself, they are making their fruit juice. Now the point is, if they are now how they will sort, how they will grade the mangoes, they will do the chemical analysis. So if you and it will take some more time. You are sending, suppose you are having a the total batch of fruits, 100 fruits came from one farm. So in among this 100 fruits, what you will do, you will take randomly any 2 or 3 fruits, you will go for the analysis, and after analysis you will see, okay, these fruits are good. But is it a very foolproof method? Is there any guarantee that, okay, there is no other fruits which are having any bacteria or not? We don't know this, because in 100 pieces of the mangoes we have tested only 2 or 3 mangoes. What will happen with rest of the other mangoes? We don't know about this thing. So if you have this NIR technology, with this technology you can check each and every fruits in a fraction of a second. It will hardly take 15 minutes. If 100 fruits you will take, just you will touch, it will show, touch, it will show, touch, it will show. So with this, it will help to give a conclusion about the food safety and the quality enhancement of the food products and fruits. What are the different advantages of the NIR technology in various fields? It is totally non-destructive, non-invasive analysis. So in this analysis, what we can see, you can do the analysis of meat, that means any food product, any fruits, any vegetables, anything. If you take any food product, you just keep in the NIR spectrometer, keep it this in the sample holder, and you switch on that machine. The IR will come, it will fall down on the sample, and after falling down on the sample, definitely it will gather some information about the sample, and it will detect the graphs and the values itself, what is the quality parameter of that particular food product, what is the protein amount, what is this carbohydrate amount, what is the fiber amount. If it is not good for your health, with these parameters you can check it. Also, if you are going to if you're going to test your this lipid profile, your sugar level of this blood, what we will do, we are going to the this dispensary, and we are giving our blood. They are doing the chemical analysis, and they are telling this. So sometimes they will take 1 day or 2 days time to give us the report. No, with the NIR technology, it is very fast, it is very rapid. Just you keep one small sample, one small drop of your blood, immediately by using NIR technology, it will show what are the different parameters present in the bloods and what are the amount of those parameters present in the blood. These are some more other applications of the NIR technology. So we can use the NIR spectroscopy in grains, cereals and legumes. That means to check the quality of those, to check the quality of poultry and beef products, to check the quality of pharmaceutical and medical sciences, to check the quality of this different fruits and vegetables, oils, and also beverages. Now coming to the summary. What is the summary here? So farmers need non-destructive, accurate, rapid and user-friendly and also eco-friendly tools to use on the farming to give them the detailed information on the physical and chemical properties of the crops at every stages of their growth, and they also need to monitor the maturity and quality of the products. If you produce some this kind of instrument to the farmers, definitely with time to time they can check in their growing stage, they can check the quality and they can monitor about the quality and their maturity with this kind of technology. Next is what the spectroscopic research is progressing rapidly as stakeholders in the food industry realize the benefits it brings to their value chain. NIR technology can add value to any agricultural business in terms of production on the farm, processing, logistics, service and marketing, giving them a competitive advantages. Next is what significant progress in NIR spectroscopic research in spectral scanners and imaginary is now combined with the state-of-art chemometrics. So with the chemometrics also you can have more impactful results in this particular topics. Simultaneously, there has been miniaturization of technology and also creating small portable devices which is more convenient to handle it. It's a very handy. So in the fields we can use, in the farms, in the greenhouses or in the laboratory itself. Thank you so much. These all things about this topic. So what I told in the first itself, this has been proved maybe with this this presentation that yes, NIR technology can prove itself as a promising tool to resolve some problems in food science and food technology, and it has proved as a promising tool for the food industry. Thank you so much.